Wagwan, my GCSE science students. In this video, we're going to be looking at the chemistry paper 1 content chapter 4. Okay, as you can see here, we're going to be looking at the chemical calculations chapter for the AQA science board. Okay, so for this video, we're going to be looking at the relative masses and moles. We're going to be looking at equations and calculations, masses to balance equations, expressing concentrations, and if you're a triple science, right, going forward, we're going to be looking at the percentage yield, which is for triple science content only. We're going to be looking at atom economy, titrations, and volume of gases. Okay, so if you're combined higher, you only need to watch the video up to C4.4. All right, so let's do this. So the first chapter, relative masses and moles. Okay, so before we do this chapter, one of the first things that you need to know is the difference between relative atomic mass, RAM, and relative formula mass, MR. Okay, so the symbol for relative atomic mass is AR. The symbol for relative formula mass is MR. So in terms of definition, AR is just the average mass of an element, comparing it to 1/12, the mass of carbon 12. Okay, everything in the periodic table in terms of mass is compared to this element, carbon 12, whereas MR is adding all the AR values together. Okay, so for example, the AR for oxygen is 16. So when you look at the periodic table, you're going to see 8, you're going to see 16. So that value there is the AR, the relative atomic mass. However, the MR for oxygen molecule, all right, is 16 times 2, which gives you 32. Hopefully that makes sense. So if you want to calculate the relative formula mass of a substance, such as water, in which the formula is H2O, as you can see there, the mass of oxygen is 16, the mass of hydrogen is 1, but inside water we have 2 hydrogen. So what we need to do, that's going to be 2 times 1, okay, and these numbers here, we're getting them from the periodic table. Okay, so just to be clear, that is from the periodic table. Alright, so it's 2 times 1 plus 16, and that gives you a relative formula mass of 18. Okay, so let's have a look at doing some calculations for some of these. So here's another example. So we have nitric acid, which is the formula HNO3. Alright, and it's very important that you remember that MR has no units. Okay, so what will happen here is that hydrogen is 1, nitrogen is 14, oxygen is 16. We're getting all these values from your periodic table. Okay, so it's going to be 1 times 1 plus 14 times 1 plus 3 times 16, and that gives you 63. All right, good. So that's relative formula mass. So here are some now that feel free to pause the video and then you can try them. I've put the relative formula mass here. All right, and we can go through them together. So what's going to happen now is that for ZnSO4, okay, so we have 1 Zn, so that's going to be, so we're doing A, so it's going to be 1 Zn, so it's going to be 1 times 65 plus our sulfur, which is 1 of that, so it's 1 times 32 plus oxygen, which is 16 times 4. You do all of that together, you should get an answer of 161. Okay, then let's look at B. So we have 2 iron, so that's going to be 2 times 56. Okay, plus you're going to have 3 times 16, and if you do all of that correctly, you're going to get 160. And then this one now, which we have a bracket that I've put there, we have 2 aluminium, so that's going to be 2 times 27 plus this bracket means that I have 3 carbon, so that's going to be 3 times 12 plus it's going to now be 9 oxygen. Okay, 3 times 3 is 9, so that's going to be 9 times the amount of oxygen, which is 16, and if you've done all of that correctly, that should give you 234. Okay, so check your answers. All right, there's all of them there. Pause the video, do what you need to do, make sure that you understand. All right, moving on. Next thing that we need to know now is how to calculate percentage by mass. And to calculate percentage by mass is the number of atoms of the element times by the AR of that element over the MR of the element, which we've just done, and you're timesing all of that by 100. So here's an example that we're going to do. We're now going to be doing the the percentage of by mass of water. So percentage by mass of water, which is oxygen. So what we're going to do is it's going to be 16 because we're trying to find oxygen. Okay, good. And in the periodic table, the AR for oxygen is 16 and the AR for hydrogen is 1. So it's going to be 16 over 1 times 2. Okay, as there's 2 hydrogen plus 16, and you're going to be timesing that by 100. Okay, so it's going to be 16 over 18 times 100, which gives you 89%. So what this means is that 89% of the mass of water is oxygen. Okay, good. So let's clear all of that. And there's your calculation. Feel free to look through. And remember, you're getting these values from the periodic table. Okay, so check your periodic table as you are going through this video. So here is a past paper question that we're looking at. So we're calculating the percentage by mass of oxygen in carbon dioxide. Okay, and this is the equation given. They've given you the relative atomic mass. Carbon is 12, oxygen is 16. So it says calculate the percentage by mass of oxygen in carbon dioxide. So in carbon dioxide, I have 2 oxygen. So that's going to be 2 times by 16 divided by the MR, the relative formula mass of carbon dioxide. So that's going to be 12 for the carbon plus 16 times 2, all in bracket. We're going to times that by 100. So that works out to give me, all right, so 2 times 16, that is 32 over 44. We're going to times that by 100, and that should give you an answer of 72.7%. Okay, so your answer is 72.7%. All right, so if you got that right, well done. Okay, moving on. So now we're looking at what exactly is a mole. But in order to explain what a mole is, it's always a good idea for you to have an understanding of some other measurement. So for example, if I say I have a dozen of something, how many is that? That simply is 12. If I say I have a couple means 2. All right, but when I talk about mole, I'm talking about atoms, and it's a very, very big number. This number, 6.02 times 10 to the 23, which is a massive number. So that means that you're moving the decimal places 23 places to the right. Okay, so a mole is any amount of substance which contains this number. I wish I was a molinaire. Okay, good. Anyways, moving on. So for this chapter, there are two main equations that you need to know. Okay, Mr. Moles has mass on his head, so that's what I use to remember this equation. Okay, the Mr. MR, okay, relative formula mass, moles has mass on his head. That's what I use to remember it. The MR or AR, depending on what the question is asking. And also, the number of particles is equal to the number of moles times, this is Avogadro's number here. Those are the two equations that you need to know. Avogadro's number. What do I mean by Avogadro's number? Avogadro's number is 6.02 times 10 raised to the 23rd. Okay, so let's have a look now at some questions that can arise from this. So, first one, calculate the number of moles of each of the following substance and give your answer to 3 significant figures. So here they've given you the mass and they want you to calculate the moles. So remember, to calculate moles, I just go back and remind you right here. Remember, Mr. Moles has mass on his head. Okay, so if I want to work out moles, moles is equal to mass divided by MR. Okay, so it's going to be 90 divided by, we're going to work that out, so it's going to be 2 times by 1, I'm getting the 1 from the periodic table, plus it's going to be 16 times 1. I'm getting that 16 from the periodic table, and if you've done that correctly, that should give me 5.00. It's set to 3 significant figures. Okay, good. Next up, calculate the number of moles here. So again, we know the equation. Okay, mass divided by mR, so it's going to be 20 divided by 4, as I have 4 carbon there, times 12, which I'm getting from the periodic table, plus 10, as I have 10 carbon there, times 1, which I'm getting from the periodic table, the 10, and that should give me an answer of, if you've done that correctly, that should give you 0.345, okay, moles. Good. And next up, again, so just remember, moles is equal to mass divided by mR. Let's see if you got them right. So it's going to be 685 divided by 1 times 14, getting the 14 from the periodic table, plus 3 times 1, getting the 1 from the periodic table. So that should give you an answer of 40.3. Okay, so you can always check your answers there. Good. Now, they can also now give you the moles and then ask you to calculate the mass. And of course, you just need to think about that same equation which we've done, which is Mr. Mose has mass on his head. Okay, so let's go. If I now need to work out mass is equal to mR, and I'm timesing that by the number of moles. So the mR here is going to be 14, which I'm getting from the periodic table, times 2, as there are 2 nitrogen there, and I'm timesing that by 4. Okay, and that's going to give me an answer of 112 grams. Good. Next up, again, we know the formula for finding mass. It is going to be mR times by moles. Okay, so it's going to be 0.1. We're going to times that by, we now need to work out the mR, so it's going to be 1 times 1 plus 1 times 14, which I'm getting from the periodic table, plus 16 times 3, the 16 I'm getting from the periodic table. Okay, work out all of that in your bracket, and if you did that correctly, you should get an answer of 6.30 grams. Good. And then finally, for this calculation, okay, it's going to be 0.02. We're timesing that by potassium is 39, which I'm getting from the periodic table. Okay, so that's 39 times 2. Put that in a bracket, plus 16 times 1, and that will give me, once you've done that correctly, that's going to give me an answer of 1.88 grams. Okay, so you can check your answers, see if you get them correctly. Okay, feel free to pause the video at any point, do your calculations, get your practice in. All right, so that's it for 4.1. Now we're moving on to 4.2, which is equations and calculations. Okay, so for equations and calculations, always just go to your calculation card, and I have my calculation card set up there. Always just have that drawn. Okay, so we have our equation, and we know the relationship that 2 moles of calcium from the balance equation reacts with 1 mole. Even though I'm not seeing the 1 there, there is a 1 there. Just like in math, when you have 1x, we don't write 1x, we just write as x. So 2 moles of calcium react with 1 oxygen, and it forms 2 moles of calcium oxide. So the question says, what mass of oxygen will react with that 60 grams of calcium? So what do we know in the equation, okay, or in this question? So the known is we have 60 grams of calcium, so that's my known. So I'm going to label my card that I know my calcium. Good. And then what's my unknown? What mass of oxygen, which is what I'm trying to find, my unknown is oxygen. So what's the mass? I have that 60 grams. Okay, what is my mR? Or in this case is AR, because I'm dealing with an element. It's going to be 40. I get this from the periodic table. Okay, so let me just put that there. Then to work out moles, remember we said that moles is equal to mass divided by MR, so it's going to be 60 divided by 40, which gives me an answer of 1.5 moles. Good. Then what's the ratio? I get the ratio from the equation shown there. So for every 2 moles of calcium I have, it will react with 1 mole of oxygen. Okay, so if I have 1.5 moles, it's going to be 1.5 divided by 2, which gives me 0.75. Okay, so notice how this is working. We're working all the way going back here, which will give me my answer there. What's the MR for oxygen? That's going to be 16 times 2, getting that 16 from the periodic table. Okay, good, so that's giving me 32. And then how do we work out mass? Mass is equal to MR times by moles, which we now both have. So it's going to be 32 times 0.75, which will give me 24 grams. Okay, so the key thing that you need to know here is how to set up your equation card. And I just do triple MR. Mass MR moles ratio. That's what I use to set up my calculation card. Okay, so here's your answer. You can check that, pause your video, work through. Okay, good. Now here's another question, because doing one question doesn't help us. I would always in my videos try to do at least 3 questions to make sure that you understand. So calcium carbonate decomposes on heating to give calcium oxide and carbon dioxide. Equation is balanced. I have the AR there. What mass of calcium oxide can be produced from 25 grams of calcium carbonate? All right, and I set up my calculation card as shown there. So what is my known? I know the mass of calcium carbonate, and I'm trying to find the mass of calcium oxide. Okay, good. So what is my mass? 25 grams. What is my MR? So remember, we're going to get our MR from the periodic table. So it's going to be 40 plus 12 plus 16 times 3. And if you do that correctly, you're going to get 100. Okay. Then how do we work out moles? It is mass 25 divided by MR, which is what we just worked out, 100. That gives you 0.25. What's the ratio? The ratio is 1 to 1. How do I know this? The equation is balanced. There's nothing in front, so we know everything is 1 to 1. Therefore, it's going to be the same amount of moles there. My MR for calcium oxide, okay, is going to be 40 plus 16. That's giving me 56. Okay, and then therefore to find the mass is going to be 0.25 times by 56, which is going to give me 14 grams. Okay, good. All right, so therefore you can check your answers there. Feel free to pause the video, and we're moving on. All right, good. So our next thing is we now have a look at an exam style question. Okay, this is 5 marks. All right, and there's a lot that we do in this. So masses from equations. So it says here that gold reacts with the element in group 7 of the periodic table. So 0.175 of gold reacts with chlorine. That's the balance equation shown there. Calculate the mass of chlorine needed to react with 0.175 grams of gold. Give your answer in milligrams. 5 marks. Okay, now you probably look at this thinking it's very difficult, but it isn't. All right, always set up your calculation card. Even if you don't get the full marks, you can get marks for your working. So what is my known? My known in this question here is gold. I know the mass of gold, AU. All right, and what's my unknown? I'm trying to find Cl2. So what's the mass? 0.175. What's the MR, or in this case AR? Why AR? Because it's just an element. The AR for gold is 197. Therefore, I now need to work out the moles. So it's going to be 0.175 grams. That's going to be divided by 197. Okay, depending on the calculator that you have, but I'm getting 0.0000888 recurrent. Okay, good. So what's the ratio of gold to chlorine? The ratio of gold to chlorine is 2 to 3. For every 2 moles of gold, I need 3 moles of that to be reacted. So what do we do here? It's going to be 0.000888, all right, times by 3 over 2. It's a direct ratio, okay? Good. So it would be, you times it by 3, divide it by 2, okay? You're cross multiplying. So once your math skills is good, you know why I do 3 over 2 there. All right. And when I do that, I am getting an answer of 0.00133. Okay, good. Then my MR is going to be 35.5 times by 2, which is giving me 71. I'm getting that from the periodic table, or the AR shown there. So it's going to be 71 times by 0.00133, okay? And that's giving me an answer of 0.0946 grams. But remember, the question said they wanted it in milligrams, so I have to divide my answer by 1,000, okay? And that's going to give me times my answer by 1,000. Apologies, times my answer by 1,000, as it's grams to milligrams, and therefore what's going to happen here is going to become 94.6 grams. Okay, good. So have a look at that, pause the video, look at what I've done. Here is the mark scheme. You can see every step where you're going to be getting your marks from. If you notice in the mark scheme, it says allow a correct calculation using an incorrect mode. So even if you got this wrong, you have something called ECF, error carry forward, which works it down and you can still get marks. Okay, allow a correct conversion using an incorrect calculation, so you can still get marks. Never give up. Okay, always be positive. All right, so now we're looking at chapter 4.3, from masses to balance equation. Okay, so from masses to balance equation, we use a similar approach. Okay, so we have the formula, we have the mass, the MR, the moles, the ratio, and then the whole number ratio. Okay, so what we tend to do here, we list out everything that's given in the question. So let's go. We have the masses, okay, and we need to use the masses to now write a balanced symbol equation. So we need to work out the MR. All of these are given on the periodic table. So 23 for sodium, plus 14 for nitrogen, plus 16 times 3. Okay, good. And that's going to give me an answer of 85. Okay, so we're going to have 23 again, plus 14, plus now we're going to have 16 times 2. Alright, and that's going to give me an answer of 69. And then this is now going to be 16 times 2, which is going to give me an answer of 32. Okay, so now to work out the moles, it is mass 8.5 divided by 85, which gives me 0.1. Then you're going to have 6.9 divided by 69, which gives me 0.1. And then we're going to have 1.6 divided by 32, which gives me 0.05. Now the ratio, we divide through by our smallest numbers. So it's going to be 0.1 divided by 0.05. That's going to give me an answer of 2. So 0.1 divided by 0.05. Okay, let me just check that. That's giving me 2. And then we're going to have 0.05 divided by 0.05, which gives me 1. Okay, so what's the whole number ratio? 2 to 2 to 1. Therefore, what's my balance equation? 2NaNO3 going to form 2NaNO2, plus I'm going to have my oxygen there, which is 1 of that. You can check if it's balanced. 2 times 3 is 6. 2 times 2 is 4. Add 2 makes it 6. 2Na, 2Na, 2N, 2N. Equation has been balanced. Okay, good. So let's have a look. Here are your steps, so you feel free to pause the video and have a look. Alright, so that's my balance equation. Good. So what would it look like if it comes on an exam? It would look something like this. A teacher found that an oxide of copper produced 2.54 grams of copper and 0.72 grams of water. And I have the two possible equations there. Determine which is the correct equation, and all of that is shown there. Okay. So what we do is that we set up our calculation card, which looks something like that. So we look at the formula. Okay, so we now look at, we said we have copper, we also have water. Okay, so what are the masses given? So for copper I have 2.54 and for water I have 0.72. So the MR, or in this case AR for copper, is 63.5, and then for water it is going to be 18. Okay, so where am I getting that 18 from? Just to be clear, it's going to be 2 times 1 plus 16, okay, which is the MR. That's where I'm getting that 18 from. So to work out the moles, it is going to be mass 2.54 divided by 63.5, and this is going to be 0.72 divided by 18, and that's going to give me an answer of 0.04, and this is also now going to give me an answer of 0.04, which means my ratio 0.04 divided by 0.04, which gives me 1, 0.04 divided by 0.04, which gives me 1. So the ratio is a 1-to-1 ratio. And in which of these it is a 1-to-1 ratio? Have a look where 1 copper is forming 1 water, so it has to be equation 2. Can't be equation 1 because that is a 2-to-1 ratio, so it has to be equation 2. That's what it would look like. There is a mark scheme, okay? All right, you can see I've got some of these questions from physics and math tutor, but that's perfectly fine. You should definitely be going over there. Let's now have another look at another exam style question, okay? Good. All right, let's have a look there. So in this question it says that a teacher investigated the reaction of iron with chlorine using the apparatus in the above diagram. Okay, but don't worry about the diagram, it's fine. The word equation is shown here: iron plus chlorine. The teacher weighed the glass tube and the iron before the reaction, the glass tube and the iron chloride after the reaction. So what's really happening is you just have a crucible, you're heating that crucible. All right, you have a strip of iron there. All right, good. And what they're doing, they're weighing the glass tube before and after the reaction. Okay, reacting with chlorine as well. They're passing chlorine through it. Okay, good. So here are the results. All right, and this is a 6-mark question. This is the glass tube and the iron, the glass tube and the iron chloride. Calculate the simplest whole number ratio of moles of atoms to the moles of chlorine there, and then you're going to determine the balance equation. All right, so this question, what we need to do, we need to set up our calculation card. All right, never do these questions without having some sort of calculation card idea as to what we're doing here. All right, so the first thing now that we need is that we're dealing with fluorine, and we're dealing with sorry, not fluorine, we're dealing with iron. Where did I get fluorine from? We're dealing with iron atoms and chlorine atoms. Okay, so we're dealing with Fe atoms and we're dealing with chlorine atoms. All right, not Cl2, because it says we need the atoms. All right, so what are the masses? So where are we going to get those masses from? we're now going to get the masses here. So the glass tube and the iron, all right, so it's going to be 56.04 minus 51.56. Okay, good. And that's going to give me an answer of 4.48. Good. And then now we have the glass tube and the iron. So it's going to be subtracting 64.56 minus 56.04. And that's giving me an answer of 8.52. Okay. So the MR, all right, our MRs, well, it's going to be these numbers here. So for iron, 56. But in this case, it's not going to be MR. It's going to be AR. Why? Because we're dealing with atoms. But that's fine. All right. And that's going to be 35.5. Good. So to work out the number of moles is going to be 56. Rather, it's going to be 4.48 divided by 56. And here it's going to be 8.52 divided by 35.5. And I am getting 0.08, and I'm also getting 0.24. Okay, so the ratio now, what we're going to be doing, the ratio is going to be 0.08 divided by 0.08, which gives me 1, and then 0.24 divided by 0.08, and that's going to give me 3. So the ratio is a 1 to 3 ratio, which means therefore that the formula for the compound is FeCl3. Okay, so because it's FeCl3, now we need to look at the balance equation for this reaction. So they're reacting iron plus chlorine, and that forms FeCl3. Okay, hold a moment, let me just erase that so you guys can have a look. Okay, good. So it's going to be FeCl3, and now to balance that we need to put a 2 there. Why do I need to put? Because that's now going to make it 6. Put a 3 there, that's not going to make it 6, and put 2 iron there, and that is our balanced equation. Okay, good. Hopefully I tried the question before doing this, or have a look at how I do it, then try doing it on your own. Have a look at the mark scheme here. That's my answer there. Okay, now we're going to be looking at expressing concentration, chapter 4. We're going nice and steady. Well done for keeping up in the video. So which of these solutions is more concentrated and why? So clearly, if I put A, B, and C there, clearly you should be saying that C is more concentrated because I have more particles per unit volume. So the volume is the same, but I have more particles. So just that you understand what is meant by concentrated versus dilute. And for concentration, there are these 2 equations that you need to know, okay? And what I always say is that when you're applying for a job, what do you write? You write a CV. So C is beside V with mass at the top. C is beside V with mass at the top, and with mass at the top or moles at the top. So you're always writing or apply with a CV to know that they're beside each other. Okay, so these are the 2 equations that you need to know. And note dm cube, moles per dm cube. So always get your volume in dm cube. That is very, very important. So to convert from cm cube to dm cube, you should know that 1 dm cube is equal to 1,000 cm cube. Very, very important that you have a look at your calculations. Okay, so remember, when applying for a job, what do you write? You write a CV with mass at the top or moles. Okay, so now we need to find the concentration. So concentration is equal to mass divided by volume. So for number 1, it's going to be 1.5 grams divided by volume, but remember that is cm cube. We need to change that to dm cube, so it's going to be 150 divided by 1,000, and if you've done that correctly, you should end up with an answer of 10 grams per 10 grams per dm cube. So that's number 1. So number 2, again, we need to change our cm cube to dm cube. So it's going to be 5 divided by 50 divided by 1,000. Okay, good. So it's going to be 5 divided by 0.050, and that should give you an answer of 100 grams per dm cube. Okay, good. And number 3. So again, watch out for the cm cube. So it's going to be 2.3 divided by 500 divided by 1,000, and that should give you an answer of 4.6 grams per dm cube. You can also write the units like that, dm to the -3, once you don't put the line there. Okay, good. Here are your answers. Always check your answers, check it with your calculator. Good. So let's have a look at what a question could look like. So it says a solution of sodium chloride, it has a concentration. Now, they've given you the concentration, they now want you to work out the mass. But because you know your triangle, alright, when you're applying for a job, you use the CV with mass at the top. So mass is equal to concentration times by volume. So what's my concentration? 70 grams per dm cube. You're timesing it by the volume, but please remember that volume is 500 divided by 1,000. Why am I dividing by 1,000? I need to change it to dm cube. Okay, and if you've done all of that correctly, you should get an answer of 35 grams. So 35 grams is needed there. Okay, good. Alright, so here are a few to try. Alright, so we now want to find a concentration in grams per dm cube, but now we are given this in moles per dm cube. So what we need to do, right, we have the moles, but we now need to change it to mass. So all we need to do, we need to times this by the mr. So we're going to get our AR from the periodic table, so it's going to be 0.1. We're going to be timesing that by 40 plus 16 plus 1. Okay, so 40 from the periodic table. Let me just fix that for you. Made a mistake there. Okay, good. So plus 1 is going to be 0.1 times by 40, which is going to give me 4.0 grams per dm cube. Good. Here it is. Check that one. So here is another one. I have 0.2 moles of sodium hydroxide. It is dissolved in 250 cm cube of water. Calculate its concentration in moles per dm cube. Okay, so now we are changing concentration, or we're trying to find concentration. So again, when applying for a job, what do you write? A CV, okay, with mass or moles at the top of the triangle. Okay, so to find concentration is equal to moles divided by volume. So what's my moles? 0.2 divided by my volume, 250. But remember that is cm cube, so I need to change that to dm cube. Alright, so all of that is done correctly, so that should give me 0.8 moles per dm cube. Okay, good. And then I want to now find the concentration in grams per dm cube. I just need to times that by 40. Where am I getting the 40 from? The 40 is coming from the 23 plus the 16 plus my 1. All of these numbers from the periodic table, the MR, okay? So that is the MR there. Alright, and if you've done all of that correctly, you should get for B an answer of 32 grams per dm cube. Okay, good. So have a look at the mark scheme there. What it says here, scientists need to A scientist makes a solution of zinc iodide with a concentration of 0.1 mole per dm cube. Calculate the mass of zinc iodide required to make 250 cm cube of this same solution. Okay, so what we need to do now, we need to find the MR for zinc iodide. So after finding the MR for zinc iodide, let's have a look at this. So it's going to be 65 plus 127 times 2. And if all of that is done correctly, that should give you 319. Okay, so now you have the MR for that. Just remember, when applying for a job, what do you write? A CV. Okay, with moles at the top. Okay, so moles is equal to concentration times by volume. So what's my concentration? 0.100, and we're going to times that by 250. But remember, it is cm cube. You need to change that to dm cube, and that should give you an answer of 0.025 moles. Okay, so that's the amount of moles that I would need, but the question asks us for the mass. So mass is equal to, think about our next triangle there. Mr. Moles has mass on his head, so mass is equal to mr. We're timesing that by moles, which will give me 0.025 times by 319, which should give you an answer of 7.98 grams. Okay, so have a look at the mark scheme. All right, good. So if you are combined science higher, you don't need to watch this anymore. You can end the video. Thanks for watching. Make sure that you hit the subscribe button. But if you are triple science, we're now going to be looking at the triple science content. Okay, good. So if you are triple science, you need to continue watching this video, okay, as we're now going to be looking at all the triple science calculations. Okay, we're now looking at chapter 4.5, the yield of a chemical reaction. So before we can calculate the percentage yield of a reaction, we need to know the difference between theoretical yield and experiment yield. All right, so theoretical yield means that if we started out with a particular mass of magnesium, what's the maximum mass or the calculated mass that we could get from that of magnesium oxide that we could get from the magnesium that we started with? That's known as your theoretical yield, the maximum possible mass from your calculation. However, in the lab, if I actually did this reaction, the magnesium oxide that I get may not be equal to, and more often or not, is not equal to our theoretical yield when you actually carry out the experiment. And this is known as your experimental yield. Okay, so the yield is the amount of product we get, all right, and that's called the experimental yield. This usually gets compared to the calculated yield or the theoretical maximum. And to calculate percentage yield, it is the actual mass produced divided by the theoretical mass, and we times that by 100. Now, your percentage yield is never 100%, okay? And it's never 100% because of the following reasons. Some of the products may be left in the apparatus, okay, or lost in the apparatus. Your reactants that you start out with may not always be pure. Also, you may have more than one product and it may not be easy to separate, or the reaction might be reversible. Okay? This question: ethene and steam react to produce ethanol. The equation for the reversible reaction is ethene plus steam to form ethanol, reversible reaction. The reaction produces a maximum theoretical mass of 400 kilograms of ethanol from 243 kilograms of ethene and 157 kilograms of steam. A company produces, so this now, all of these now are our theoretical masses. A company produces 380 kilograms of ethanol from 243 kilograms of ethene and 157 grams of steam. So we need to know, so this is what's produced. So all of these are our actual. These are theoretical. Okay, so they want us to know the percentage yield of ethanol is less than 100%. So we now need to calculate the percentage yield of ethanol. So what was the amount of ethanol that was made? So we made 380. The theoretical is 400, and we times that by 100, and that should give me an answer of 95%. Okay, there's your mark scheme. Very, very straightforward. Let's look at another example. All right, a different scientist makes zinc iodide by the same method. The scientist obtains 12.5 grams of zinc iodide. The percentage yield now is 92%. And they now want to work out the maximum theoretical yield. So remember the equation. All right, so remember the equation. What it says is that percentage yield is equal to the actual yield over the theoretical, and we are timesing that by 100. So what do we do? What's our percentage yield? 92%. So I'm going to put that there. Is equal to my maximum theoretical yield. So what's my actual? 12.5 over x, because we don't know what that is, and we're going to times that by 100. Okay, we're going to be timesing that by 100, and therefore we now need to rearrange this equation here. So we do, so 12.5 times 100, 1250 over x is equal to 92. So x is now going to be equal to 1250 divided by 92, and that's going to give me an answer of 13.6 rounded. Okay, good. So have a look there. That's the mark scheme. Mark, 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 and let's go. So that was percentage yield. Now let's look at atom economy. So to work out atom economy, again for triple science, but what really is atom economy before we can look at that? Atom economy is a measure of how efficient the reaction is. It's the efficiency of the reaction. So what it does, it tells you the percentage of reactants that end up as useful products. Okay, so it's very similar to the physics efficiency formula, and here you go. So it is, to find percentage atom economy, it is the MR of the desired products over the sum of the reactants, and we're going to times that by 100. Okay, so here is a question. Let's have a look at this one. So to calculate the percentage atom economy for, so let's go. Atom economy, an equation for the reaction is NiO plus C gives you nickel plus CO, which is carbon monoxide. Calculate the atom economy for the reaction to produce nickel. So nickel is now nickel is the desired products, and now we've given all of these MRs here, and we need to give our answer to 3 significant figures. So remember, to work out percentage atom economy, it is equal to the desired product, the MR of the products that we desire, over the MR of the reactants, and we're timesing that by 100. Okay, so what's the MR of the desired product? It's going to be 59 over the MR for all of the reactants. So it's going to be nickel oxide, which is 75, plus carbon, which is 12. We're going to times that by 100. So it's going to be 59 over 87 times by 100, and that gives me an answer of 67.8 to 3 significant figures. Okay, have a look. Alright, please note that you will lose mark if you don't do the correct significant figure. Okay, good. So here is another atom economy question. So look at the two reactions below. You have them there. All right. The relative formula masses are all given there. They've given you the equation. Calculate the atom economy for reaction 2. So in reaction 2, did they say what the desired product is? No, what the desired product in this case is going to be copper chloride. Okay, good. So it's going to be 134.2, which is my desired product. 134.5. I said 0.2. Apologies. Lots of numbers here. Okay, over the sum of the MR of all the reactants. So we have CuO, which is 79.5, plus HCl, which is going to be 36.5, and because it's 2 times that, we have to times it by 2. Okay, and we're going to times that by 100, and that is going to give me 134.5 over 152.5, and we're going to times that by 100, and that will give me an answer of 88.20%. Okay, good, well done. So now that's atom economy. Have a look at the mark scheme. Very important that you note why am I times it by 2, because now I have 2 HCl there. Okay, good. So now we're looking at titration again. So this is normally a core practical, all right, or required practical rather, which you need to know. So titration, what it really is a technique that is used to find out the concentration of an acid or an alkali. You're trying to find out what concentration is that acid and alkali. And normally we use these equipment in a titration. We use a burette, we use the volumetric pipette. Just to show you, we use the pipette fillers, all right, beakers, lots of glasswares, your conical flasks, indicators. Okay, so how do you read the burette? Important that you know that you read the burette at the bottom of the meniscus. Okay, and you read it from the top going down. So this is 42.1, 2, 3, and you must always give it to another decimal place. All right, so 42.30 cm cubed. Very important. Now in a titration you must use an indicator. So the indicator is important because it tells you when the solution has been neutralized, because remember you're reacting an acid and alkali. Okay, and this is called the endpoint. So the endpoint is when we've created a neutral solution. This can be seen because there's a permanent color change of that indicator. Alright, and we normally use indicators such as methyl orange, phenolphthalein. We don't use universal indicator because obviously universal indicator would have a wide range of different colors. Okay, good. So this is what the setup would look like. Alright, so the unknown solution that normally goes into your burette. Alright, and you make sure that there's no air bubbles, because if there's air bubbles there, it's gonna give you incorrect volume reading. Okay, then your known solution and your indicator that goes into your conical flask here. So your known solution will be done in your burette, in your pipette rather, and you pipette that into your conical flask. You then add your indicator. All right, you then run your unknown into your known while swirling. Okay, until that color changes. You record the volume before and after so that you can know the volume used. Okay, so things to remember: you rinse the burette with the hydrochloric acid first, or once it's the unknown, and then you discard. You rinse the volumetric flask with your sodium hydroxide, and then you discard. You carry out a rough titration to get an idea where the endpoint is, and then your real titrations ensure you add drop by drop as you get close to that endpoint. Okay, so rinse both the burette and the pipette. Okay, fill it to above 0. Use the tap to get to 0. It doesn't have to be 0, but you get your initial volume. All right, Good. Then you use your pipette to measure out the 25. Then you place it on top of a white tile. You then add your indicator. It will go pink. And as soon as it goes colorless or gets close to colorless, you slow down as the color point is near. And then you repeat this over and over until you get results which are close to each other. They use the word concordant results. And when you get those results which are close to each other, you take an average of those readings. Okay. So now we're going to look at the calculations that we do for titration. So let's go. Normally, to work out these, we always use our calculation card, CVMR. You know, I'm really big on my calculation card. So here goes. Right? So here's an exam style question. So it says here that you have 13.3 cm cube of, so this is my volume, of, that's my concentration, 0.050 moles per dm cube citric acid was needed to neutralize another volume here of sodium hydroxide. Calculate the concentration of sodium hydroxide in moles per dm cube, and you're given that as your equation. Okay, so now what we do is set up our calculation card. So what is my known? My known is my citric acid. What's my unknown? My unknown is my sodium hydroxide. Okay, so concentration 0.0500 moles per dm cube, moles per dm cube. Good. And then what's the volume? The volume is 13.3 cm cube, but we need to change that to dm cube. So it's going to be 0.0133. How do I know that? I divide that by 1,000. 1, 2, 3. All right, that's now dm cube. Very important that we change to dm cube. Then moles, remember, when applying for a job, you write a CV. So now I have moles. So it's going to be C times V. So it's going to be 0.05. You're going to times that by 0.0133. Okay, and that's going to give me an answer of a very, you're going to get this on your calculator, 0.0000665, or some calculator will give you 6.65 times 10 to the minus 3. Okay, so if you get that, is the same thing, 6.65 times 10 to the minus 3 moles. Good. Now what's the ratio? Right, if you have a look here, it's going to be 1 to 3. Okay, so for every 1 mole of citric acid, you need 3 moles of sodium hydroxide. So I need to times this number here by 3, which gives me 0.001995, or 1.995 times 10 to the minus 3. Okay, what's my volume? My volume of sodium hydroxide is 25 cm cube. Remember, you have to change that to dm cube. So I'm going to divide that. So it's going to be 0.025 dm cube. And then how do we work out concentration? Concentration is moles divided by volume. So do I have my moles? Yes. 0.00195 divided by volume, 0.025. And that's going to give me an answer of, I am getting 0.078 moles per dm cube. Okay, you could just write as a big M. All right, moles per dm cube. So let's have a look at your mark scheme. Right, I think that could be worth more marks. Okay, but that's fine. Here's another type of question that could come up in terms of titration calculation. So a student titrated 25 cm cube portions of sulfuric acid with, and they're now giving you the concentration. So this is the concentration, this is my volume. Okay, good. And after doing the concentration, these are what your values look like. So the equation for the reaction is 2NaOH plus H2SO4 to form Na2SO4 plus 2H2O. Calculate the concentration of the sulfuric acid in moles per dm cube. You need to use concordant results, the results which are within 0.01 moles per dm cube of each other. So which one are we going to use? We are going to be using, let's have a look. Which one are we using? We're going to choose concentration 3, 4, and 5. Have a look. 22.10. So it's going to be 22.10 plus 22.15 plus 22.15. All of that is going to be divided by 3. And that's going to give me an average of 22.13 cm cubed. That is my volume of sodium hydroxide. Okay, good. So now that we have the volume of sodium hydroxide, we have the concentration of sodium hydroxide, we have the volume of sulfuric acid, we can go ahead, we can set up our calculation card. Okay, so let me clear off some of these. All right, so what's my known? What's my unknown? So my unknown is the sulfuric acid. Oops, sorry. So my unknown is my sulfuric acid, and my known is my sodium hydroxide. So what do I know about my sodium hydroxide? We have been given the concentration here, 0.105 moles per dm cube. Alright, good. Then the volume, which is what we've just worked out, of sodium hydroxide is going to be 22.13, but we have to divide that by 1,000. Okay, we have to divide that by 1,000, and that would give me 0.02213 dm cube. Okay, good. Then we now need to work out the moles. So remember, CV. So to work out moles is concentration times volume. So moles is equal to concentration times volume. So it's going to be 0.2213. We're going to, and then we're timesing that by 0.105. So volume times concentration, concentration times volume. And if you've done all of that correctly, you should get an answer of 0.00234, or you know what, let me just clear that and write it properly so that you guys can see exactly what we're doing here. So if you've done all of that, you should get 0.00234, or 2.324 times 10 to the minus 3. Okay, so what's the ratio now of sodium hydroxide? 2 to my unknown H2SO4, 2 to 1. So I need to divide that by 2 to give me the number of moles on that side, okay? Or half the number of moles there, which would give me an answer of 0.001162. So for volume, our volume there is 25 cm cubed, so it's 25 divided by 1,000, which would give me 0.025. And then now to work out the concentration, concentration is moles divided by volume. So what was my moles? 0.00165 divided by 0.025. And that would give me an answer of 0.0465 moles per dm cube. Moles per dm cube. That's what I'm getting as my answer. Alright, good. So check your mark scheme there. This is what the mark scheme look like. Okay, so you can work through that. All right, so now we're on to our final topic for this chapter. It's a really intense chapter, really well done for those who made it through. So when we talk about volume of gases, we now need to look at Avogadro's molar gas volume. So what it means is, what it says is that 1 mole of any gas at room temperature and pressure, so room temperature is 20 degrees and pressure is 1 atmosphere, occupies a space of 24 dm cube. Okay, and this is what is known as molar gas volume. And to find the volume of a gas, it's going to be the number of moles times by 24, and that would give you the volume of gas in dm cube. Okay, so if I give you this question and it says what is the volume of 3 moles of oxygen at RTP, right? It doesn't matter if it's oxygen, hydrogen, whatever the gas is, the same moles of gas will occupy the same number of space. So all we need to do is going to be 3 times 24, which gives me 72 dm cube. All right, so remember, 1 mole of any gas will occupy the same amount of space no matter what gas that is. Okay, good. So we've done that. That is our mark scheme. So let's have a look at this now. How many moles would I have in 48 dm cube of helium? Okay, so remember what we said, moles times 24 is equal to the volume. Okay, so now if we want to find moles is going to be equal to the volume divided by 24, which is going to give me 48 divided by 24, which is going to give me 2 moles. Okay, so that's what it would look like. Okay, good, using molar gas volume. All right, so have a look at this one. I now have 22 grams of a hydrocarbon and it has had a volume of 6 dm cube. We now need to find its molar mass. Okay, so now we know that moles is equal to the 6, which is the volume, divided by 24, which is the molar volume. So now we know that is 0.25 moles of that hydrocarbon there. Then we remember that Mr. Moles has mass on his head, so MR is equal to mass divided by moles. So for those who don't remember Mr. Moles has mass on his head. So to find MR is mass divided by moles. What's the mass? 22 grams divided by the moles, which we've just worked out, 0.25, which is now going to give me an MR of 88. Okay, good. So remember Avogadro's gas law. Okay, good. Now you may be asked to calculate the volume of gas needed or producing a reaction, and in order to do that, again we go back to our calculation card. So we have mass, MR, moles, we have ratio. Okay, so now let's have a look at this question. So it's given you that magnesium carbonate is an ingredient in some antacid medicines. When it is added to the stomach acid, the following reaction takes place. So you can see that reaction there. What mass of magnesium carbonate reacts to form 6 dm cube of carbon dioxide? So what's my known? I know the mass of, not the mass rather, I know the volume of carbon dioxide. I'm trying to find the mass of carbon dioxide of magnesium carbonate. My bad. Lots of calculations here. MgCO3. Okay, good. So 6 dm cube, that's my volume. Okay, good. Now we now know that we have not MR in this case. What we know, we have the molar volume, okay, which is 24 dm cube. Okay, because this is taking place at room temperature and pressure. Now we need to work out the volume, the moles. So moles is equal to the volume divided by the 24. Okay, so it's going to be 6 divided by 24, which gives me an answer of 0.25 moles. So what's the ratio? Now, the ratio of carbon dioxide is 1 to magnesium carbonate, also 1. So it's going to have the same amount of moles here. Alright, going back in this end, we now need to work out the MR for magnesium carbonate. So magnesium carbonate, that's going to be 24 plus 12, which is carbon, plus 16 times 3, which gives me an answer of 84. So therefore now, to work out my mass, which is what the question is asking you, it's going to be 0.25 times by 84, and that will give me an answer of 21 grams. Okay, so the key thing is the calculation card sometimes can be a little bit tricky, so it depends on what the question is asking you. Okay, so you have your volume, your molar volume, your moles, your ratio. Going back around is not the same thing, so it's MR and then it's going to be mass, but it depends on what is being asked in the question. Okay, good. So that was my mark scheme there. All right, so well done for reaching this far in the video, and just remember to hit the subscribe button, and all the best in your GCSEs. I am out.